Imagine a traveller from deep space, a body that does not belong to our solar system, cutting across billions of miles of emptiness to arrive here. Astronomers named it 3-Eye Atlas. That I stands for interstellar. Atlas is not a comet from the Kuiper belt or the Oort cloud. It comes from somewhere else entirely. It carries ice and dust forged around a different star, a different sun, a different history of chemistry than anything we know. Atlas is moving on a path that makes experts uncomfortable. Normally comets follow rules. Their brightness changes as they warm. Their tails grow in predictable ways. Their orbits can be calculated to the second. Atlas is different. It brightens and dims without warning. It throws off gas in violent bursts. Its orbit does not match our models. Some scientists describe it as a cosmic tantrum, a body that refuses to behave. On October 3rd, 2025, Atlas will pass close to Mars. Not close in human terms, but close in the language of the universe. About 30 million kilometers. That sounds like a safe cushion. 75 times the distance from Earth to the Moon. But in astronomy, this is what is called a near miss. For an object that unstable the margin is uncomfortably thin, this is not a movie script. It is real. The European Space Agency and NASA have been watching Atlas with the intensity of bomb technicians diffusing a live charge. Every flare, every unexpected surge of brightness, every tiny wobble in its path is logged, and still nobody can say with certainty what it will do when it sweeps past Mars. For the first time in history, humanity is watching an interstellar body interact closely with a planet we intend to colonize. Mars has always been the next step. The red world has been in our imagination for decades, rovers crawling across its deserts, orbiters mapping its surface, engineers designing habitats for future astronauts. But all those plans assumed one thing, that Mars would be stable, that it would remain the quiet, predictable neighbour we have studied for half a century. Atlas could change that in a single day. So what exactly is at stake on October 3rd? Scenario 1, nothing happens. Atlas sails past Mars, spins on, and scientists collect data that becomes another chapter in the story of interstellar visitors. That is the optimistic outcome. But optimism is not what keeps planetary defense experts awake at night. What if Atlas breaks apart as it nears Mars, scattering fragments across the inner solar system? What if one piece, just one, takes a path toward the red planet? Imagine a chunk of rock, the size of a city block, travelling faster than a bullet hitting a planet with no thick atmosphere to slow it down. The crater would be wider than most cities on Earth. Dust would rise into the thin Martian sky and wrap the planet in a choking haze. Every rover, every lander, every mission could be silenced, and the dream of colonizing Mars could be delayed for centuries. Even without impact, the risks remain. Atlas carries a massive cloud of gas and dust, its coma, that stretches for millions of kilometers. If that coma interacts with Mars, it could spark electrical storms, disrupt communication, or even seed the planet with alien chemistry. Think about that. A planet we plan to land on permanently altered by material from another star. October 3rd is not just another date. It is a test of how much we understand about objects that do not belong here. A test of how fragile our plans for the future really are. No one doubts the scientific value of this encounter. Telescopes around the world are focused on it. Space agencies are preparing their orbiters to capture every possible detail. But beneath the calm language of official reports, you can sense the unease. Atlas is not acting like anything we have seen before, and that makes predictions unreliable. Here is the uncomfortable truth: we do not know what will happen. And that uncertainty is the real danger. Think about how humanity responds to threats. Earthquakes, hurricanes, pandemics. We study them, we model them, we prepare. But Atlas is different. It comes from a place we have never seen. It moves in ways we do not fully understand. It could pass by and leave us with nothing but data. Or it could mark the first real test of our species' ability to respond to a cosmic threat. October 3rd, 2025 is the moment of truth. The question is not just what Atlas will do, The question is whether we are ready for what it might bring. Are we prepared for fragments that turn Mars into a graveyard of machines? Are we prepared for electromagnetic storms that cut our links to orbiters and rovers? Are we prepared for the possibility, however small, that Mars could become, contaminated with chemistry we have never seen before? Most importantly, are we prepared to accept that the universe is not under our control? This is why scientists, politicians, and the public are watching. Because the worst-case scenario is not just about Mars, it is about us. About our future as a species that plans to leave Earth and live on other worlds. If Atlas teaches us anything, it may be that the universe does not care about our plans. So mark the date. October 3rd, 2025. The day we stop assuming Mars is safe. The day we face the possibility that our next home could become our greatest warning. If Atlas refuses to follow mathematics, every prediction of safety collapses. For centuries, astronomy has been built on trust in numbers. The universe looks chaotic, but planets and comets move with precision. Their paths can be described by equations. If you know the mass, the speed, and the angle, you know where the object will be tomorrow, next year, even centuries from now. Atlas is breaking that trust. Observers have already seen the comet flare up dim and shift in ways that do not fit the math. The worry is not just that Atlas is unpredictable. The real fear is what happens if it comes apart near Mars. Fragmentation is not science fiction. We have seen comets split before. Pieces scatter in every direction. Some drift harmlessly into space. Others slam into planets or moons. When a body fractures, each fragment makes its own rules. They stop obeying the original orbit and start following trajectories shaped by momentum, gravity, and chance. Now imagine this happens with Atlas, a comet the size of a small mountain breaking into a storm of rocks and ice. Most of it keeps flying, but one piece, a single fragment, gets nudged toward Mars. Picture that fragment. Not the size of a planet, not even the size of a mountain, just the size of a neighborhood block. A chunk of rock and ice, maybe 300 meters across. It does not sound like much, but it is traveling faster than any missile, faster than any jet. The energy packed into that one piece is equal to thousands of nuclear warheads. If it hits, the result is immediate. A crater dozens of miles wide. Shockwaves racing across the Martian surface. The blast hurling debris into the sky until the entire planet is wrapped in dust. Close your eyes and imagine it. The red desert vanishes under a shroud of brown and grey. The thin Martian atmosphere, already fragile, fills with choking particles. The sun disappears. Daylight fades. For months, maybe years, Mars becomes a cold, dark world. Temperatures crash. Solar panels die. Every machine we have sent there, rovers, landers, orbiters, goes silent. This is not exaggeration. Mars has no protective atmosphere like Earth. On Earth, small meteors burn up before they reach the ground. Our atmosphere acts like a shield. Mars does not have that shield. Anything big enough to reach the planet will strike with full force. Think about the cost. Decades of missions. Billions of dollars. Thousands of careers spent designing, launching, and operating these machines. All gone in a single impact. Curiosity. Perseverance, ingenuity, the names that made headlines and inspired classrooms buried in silence. And here is the most sobering point: it does not take a giant fragment to do this. A rock the size of a football stadium could erase everything we have placed on the planet. This is why experts worry less about a direct hit from Atlas itself, and more about what happens if it shatters. The parent body might pass by harmless. But its children, the fragments, could rewrite history. The image is stark. Mars, once the symbol of our future, becomes a graveyard. Not because of one massive collision, but because of debris we cannot track, fragments too small to see until it is too late. And the danger does not end with the first strike. A major impact would inject so much dust into the atmosphere that it could trigger planet-wide storms. We have already seen how Mars experiences seasonal dust storms that cover the entire planet. Multiply that by 10. The skies would remain opaque, no sunlight, no power for solar arrays, no line of sight for cameras. Our orbiters would circle a world hidden under its own smoke. The surface would freeze. Any water near the topsoil would lock into ice. Temperatures would plummet well below what our electronics were designed to handle. Even nuclear-powered rovers would struggle. Their systems are built for the Mars we know, not the Mars covered in post-impact winter. This is the nightmare scenario of orbits refusing to play by the rules. We trust in the math to tell us Atlas will pass safely by. But if Atlas fractures, the math becomes chaos. Prediction fails. Safety becomes illusion. And here is the hardest truth to face. All it takes is one fragment. One neighborhood-sized piece of ice and rock. One unpredictable shift. One strike. That is enough to erase decades of progress and push the dream of Mars colonization into the distant future. So when people ask, what is the worst that could happen, this is one of the answers. Not the end of Mars itself, but the end of our foothold there. Not extinction, but a setback so massive it could reshape humanity's space ambitions for generations. The question remains, if Atlas does not follow the rules, are we ready for what happens next? When people think about cosmic disasters, they picture impact craters, explosions and fireballs lighting up the sky. But not every threat needs a collision. Some of the most destructive forces are silent, invisible, and harder to prepare for. Atlas does not have to hit Mars to change it forever. Atlas is carrying a massive shroud of gas and dust, its coma, that stretches millions of miles in every direction. Inside that coma are particles that become ionized when exposed to sunlight, forming plasma. Plasma is not harmless. It conducts electricity, distorts magnetic fields, and carries energy in unpredictable ways. And Mars, more than any other planet in the inner solar system, is vulnerable to this kind of assault. Unlike Earth, Mars no longer has a global magnetic shield. Billions of years ago it had one, but it collapsed. What remains are scattered patches of crustal magnetism, small islands of protection in a sea of exposure. That means any charged particles streaming off Atlas will not bounce away. They will pour directly into the Martian atmosphere, changing it from the top down. Imagine the scene. Atlas sweeps past, trailing its coma. Waves of plasma hit Mars. The planet glows with auroras, not the faint green and red ribbons we see near Earth's poles, but curtains of light stretching across the entire sky. These auroras are not gentle. They are violent, chaotic, flickering across the horizon, pulsing like a strobe light. From orbit, Mars would look as if it were wrapped in a glowing storm, and with that light show comes disruption. Radio waves cannot travel cleanly through ionized air. Communication signals scatter, fade, or vanish entirely. Our orbiters, MRO, MAVEN, the Trace Gas Orbiter, depend on steady radio links to Earth. If plasma floods Mars's upper atmosphere, those links could fail. Now picture the chain reaction. A spacecraft loses its star trackers because the glow of auroras blinds its sensors. The onboard computer cannot confirm orientation. The satellite slips into safe mode. Then another, and another. One by one, our machines in orbit around Mars shut themselves down, waiting for instructions that cannot reach them. On the surface, the situation is no better. Curiosity, perseverance, and ingenuity rely on orbiters to relay data back to Earth. Without that relay, they are stranded. They can still operate, but their voices cannot carry across the gulf of space. Engineers at mission control send commands, but nothing comes back. The rovers sit in silence, wheels still, cameras dark, waiting. From Earth, the silence would be deafening. Every day, scientists expect fresh images from the Martian surface weather reports, from orbiter signals that confirm our presence on another world. Instead, the screens show nothing. No telemetry, no pings, just static. This is not a temporary blackout measured in minutes. Plasma storms can last for days or weeks. Imagine the anxiety building with each passing hour. News outlets speculate wildly. Social media fills with rumors. Is Atlas destroying our spacecraft? Did we lose Mars entirely? Are governments hiding the truth? The terrifying part is that none of this requires an impact. Atlas does not have to strike a single grain of Martian sand. All it needs to do is pass close enough for its plasma cloud to interact with Mars's weak defenses. The physics are harsh. Charged particles spiral into the atmosphere, colliding with molecules of carbon dioxide, nitrogen, and oxygen. Each collision creates light heat and electrical currents. Those currents surge through the upper atmosphere, creating conditions spacecraft were never built to handle. Cables become antennas circuits, experience spikes, sensors register false readings. For engineers on Earth, there is almost nothing to be done. Spacecraft are designed for known threats: solar storms, radiation, micrometeorites. They are not built to survive the unpredictable chaos of an interstellar comet, with behavior no model has ever tested. Close your eyes and imagine Mars during this storm. The planet is wrapped in ghostly curtains of light shimmering in every direction. Lightning flickers through dust storms charged by incoming plasma. The skies are alive with electrical chaos. Yet if you were standing on the surface, you would not hear anything. No sound, no roar, just silence under a sky that refuses to stay still. Meanwhile, on Earth, the silence is even worse. No new pictures of Martian landscapes, no updates from rovers, no science reports from orbiters, mission teams refreshing consoles that show only blank screens. It is not just the loss of data, it is the feeling of blindness. For the first time in decades, we would have no eyes on Mars. Think about what that means for the larger mission of humanity. Mars is not just a scientific target, it is a symbol of our future. It is the planet we intend to colonize, the backup home for our species. Losing contact, even temporarily, shakes that vision. If a single interstellar visitor can reduce us to helpless silence, how ready are we really to live there? And here is the worst part. Even after Atlas passes, the damage may not end. Plasma storms can leave lasting changes in an atmosphere. They can strip gases away, alter chemistry, and leave behind unstable conditions. The auroras might fade, but the interference could linger, disrupting communication for months. This is the nightmare of invisible shockwaves. No fireballs, no craters, just silence disruption, and the realization that our technology is more fragile than we admit. The lesson is simple. Impacts are easy to imagine. We have seen movies, read books, watched simulations. But the most dangerous outcome may be the one that does not make a sound. A storm of charged particles, unseen, unpredictable, capable of isolating an entire planet from us. So when you think about Atlas and Mars, do not only picture rocks slamming into red deserts. Picture a world glowing with unnatural light, cut off from its explorers, drifting in chaos while Earth waits and listens to nothing. Because sometimes the worst case is not what hits you. It is what blinds you, what silences you, what leaves you staring at empty screens with no answers. What happens if Atlas carries something that does not belong to our solar system? When people talk about threats from space, they usually mean rocks dust or radiation. But there is another possibility, one that is harder to measure and far more unsettling: biology. The idea is called panspermia. It suggests that life, or at least the building blocks of life, can hitch a ride on comets, asteroids, or fragments of planets, and spread across the galaxy. Microbes frozen in ice, organic molecules sealed inside rock, carried for thousands, even millions of years until impact or dust deposition delivers them to a new world. Now apply that idea to Atlas. This comet is not local. It did not form in the familiar cold reaches of our own system. Atlas comes from somewhere else, another star, another environment, another history. It has spent tens of thousands of years travelling through interstellar space, its nucleus locked in cold so deep it preserves whatever it carried when it left home. We already know Atlas is unusual. Its coma is rich in carbon dioxide, not the typical water-driven outgassing seen in most comets near the Sun. Carbon dioxide is an excellent solvent for organic chemistry. It can protect and stabilize molecules that would normally fall apart in harsher conditions. Add radiation, cosmic rays, and time, and you get the possibility of complex chemistry that Earth has never seen. Now imagine what happens when that material touches Mars. Atlas does not need to crash into the planet. Dust from its coma could drift down through the thin Martian sky. Tiny particles invisible to the human eye, but each carrying exotic chemistry. They land on the surface, they settle into the soil, they mix with water ice at the poles, they dissolve into the thin air, changing the chemistry molecule by molecule. From orbit it would look like nothing happened. But on the surface the story could be very different. Picture the Martian desert grains of red dust mixed with specks of dark powder from Atlas. In those specks are organic compounds never before seen in our solar system. Some might just sit there inert. Others might react. They could combine with native Martian minerals. They could form chains, structures, patterns that mimic the beginnings of biology. Not alive in the way we understand life, but active enough to consume resources spread through the soil and disrupt the balance. Now consider the consequences. For decades, space agencies have been preparing to answer one of humanity's biggest questions. Is there life on Mars? Billions of dollars have gone into designing rovers, drills and instruments to look for faint chemical signatures. But if Atlas dust seeds Mars with alien chemistry, how will we know what is Martian and what is foreign? How will we separate the signals of native biology from contamination? The nightmare scenario is this. Our instruments detect organics, even patterns that look biological but they came from Atlas, not Mars. The data becomes noise. We can no longer trust what we see. Every sample return mission becomes suspect. Every claim of Martian life is thrown into doubt. And then there is colonization. Imagine astronauts landing in the 2030s, building habitats, growing food, relying on Martian soil and water. What if the soil is already contaminated with self-replicating chemistry from Atlas? What if the water is laced with exotic organics that clog filters, poison plants, or corrode equipment? What if the air itself carries unstable compounds that react in ways we never modelled? Mars would not need to be deadly in the traditional sense. It would only need to be unpredictable. An environment we thought we understood, altered by invisible chemistry we cannot control. This risk is not fantasy. Planetary protection is a real field. NASA and ESA have strict rules to prevent contaminating other planets with Earth microbes. Every spacecraft is sterilized, every sample handled under protocols. But those rules were written for our own neighborhood. They never accounted for a comet arriving from another star dumping unfiltered material onto a planet we plan to settle. And even if nothing alive comes with Atlas, the molecules alone could cause trouble. Organic chemistry is subtle. Some compounds act as catalysts, speeding up reactions that normally would not happen. Others interfere with detection methods, creating false positives or false negatives. 1 gram of the wrong compound could throw decades of research into confusion. Picture it. The first human crew digs into Martian soil. They expect dust salt, maybe traces of frozen water. Instead, their instruments spike with readings that make no sense. Compounds that don't fit the models. Reactions that cannot be explained. Was this Mars, or was it Atlas? No one can say for sure. That uncertainty alone could halt colonization. Who would risk entire missions, entire lives, when the soil itself might fight back with chemistry we do not understand? Here is the most unsettling part. This contamination would not be obvious. There would be no explosion, no glowing sky, no craters. Just subtle changes spread by dust storms, by winds, by the thin atmosphere. Within weeks, Atlas material could circle the entire planet. Within months, it could touch every future landing site. And once it is there, we cannot remove it. We cannot sweep Mars clean. The contamination would become part of the planet's history, part of its environment, forever. So the question becomes, what if the worst case is not destruction, but pollution? What if Atlas leaves Mars intact, but corrupts it just enough that we can never study it? Honestly, never colonize it safely, never trust it. As a second home, October 3rd, 2025 could be remembered not as the day Mars was destroyed, but as the day Mars was altered. Changed in ways invisible, irreversible, and deeply dangerous. Because sometimes the most devastating threat does not come from fire or impact. It comes from dust, from molecules, from a biological intruder we never saw coming. If Phobos shatters, Mars's orbit turns into a minefield. Mars has 2 moons. They are nothing like Earth's moon. Instead of a single bright sphere, Mars has Phobos and Deimos, two misshapen rocks captured long ago. They are small, irregular and fragile. Phobos is about 22 kilometers across. Deimos is even smaller, only about 12 kilometers. Both are scarred by craters and fractures, evidence of their weakness. They are survivors, but barely. Phobos, the larger one, is already doomed. Its orbit is decaying. Every year it drifts a little closer to Mars. In about 50 million years it will either slam into the planet or break apart from tidal stress. But Atlas could accelerate that fate. Here is how. Atlas carries a vast halo of dust and debris. If fragments break off, some could be redirected toward Mars's moons. A single piece the size of a car travelling at interstellar speed could strike Phobos with more energy than the strongest bomb we have ever built. Phobos has cracks running across its surface, already deep grooves that may be signs of internal stress. A hit like that could be the last straw. Now imagine the moment. Instead of absorbing the impact, Phobos comes apart. The moon fractures and within minutes the pieces scatter into orbit. From a distance it would look like a cloud forming around Mars, but it would not be harmless dust. It would be a swarm of rocks, each one a projectile, each one circling the planet at thousands of miles per hour. Mars would no longer have two moons. It would have a chaotic debris ring. Picture what that means. Every spacecraft around Mars, every orbiter, every future crewed ship would face a sky filled with bullets. Unlike Saturn's rings, which are flat and mostly stable, a ring born from Phobos would be jagged, unstable and violent. Chunks of rock would follow intersecting paths. Some would crash into each other, creating more fragments. Others would fall toward Mars, burning up in the thin atmosphere or slamming into the surface. Mars' orbit would be a hazard zone for decades, maybe centuries. Think about our current missions: the Mars Reconnaissance Orbiter, MAVEN, the Trace Gas Orbiter. None of them were designed to dodge debris fields. Their thin shielding can handle micrometeorites, not a barrage of high-speed rocks. Even a pebble travelling at orbital velocity could tear through a solar panel or punch a hole in an instrument. In this scenario, losing one spacecraft would be expected. Losing all of them would be likely. And what about future missions? Space agencies dream of sending humans to Mars. Those missions rely on safe orbits for staging, for communication relays, for landings. But with a ring of debris surrounding the planet, there would be no safe orbit. Every path would cross through the minefield. Every crewed vehicle would face the risk of catastrophic impact. Phobos turning into a ring is not just a scientific problem, it is a symbolic disaster. Mars is supposed to be our next home, a place of hope. Instead, it would become a world surrounded by wreckage. A red planet encircled by its own shattered moon, daring us to try to reach it. And Deimos, though smaller and farther out, would not be immune. A collision with Atlas debris could destabilize its orbit as well. Deimos might survive the first strike, but the gravitational chaos could pull it into a path that eventually collides with other fragments or with Mars itself. The worst part is how sudden it could be. Astronomers expect Phobos to last millions of years. But one encounter with Atlas could reduce that timeline to minutes. One impact, one fracture, and Mars's skies would never be the same. So when we think about Atlas, we cannot just imagine it threatening Mars directly. We have to consider the moons. Because if Phobos or Deimos are destroyed, Mars becomes almost unreachable. And a planet we once thought of as our future turns into a fortress surrounded by an orbit of flying shrapnel. This is the minefield scenario. It does not take a global impact. It does not take a biological invasion. All it takes is one fragile moon breaking apart. And from that moment on, Mars is no longer a destination. It is a warning. What happens on Mars will not stay on Mars. When Atlas passes near Mars, most people assume the danger ends there. Either the planet survives or it doesn't. But space is not a closed box. It is a network. Every object pulls on every other. And when you add fragments from a breaking comet into that system, the consequences ripple outward. Mars is only the first domino. The next one could be Earth. Let's start with the basics. If Atlas breaks apart near Mars, hundreds of fragments scatter. Some get pulled toward the sun. Others drift into deep space. but a few take unpredictable paths through the inner solar system. Gravity from Mars, the Sun, and even Jupiter nudges them onto new courses. Once that happens, there is no guarantee they will stay away from us. Now imagine one of those fragments making its way toward Earth. Not a planet killer, not a mountain-sized rock, just a fragment the size of a building, 30 or 40 meters across. To most people that sounds small, but size is not what matters. Speed is. And Atlas fragments travel at tens of kilometers per second. At that speed, even a relatively small rock carries the energy of hundreds of nuclear weapons. We know what that looks like because we have seen it before. In 1908, over the Tunguska region of Siberia, an object about 50 meters wide exploded in the atmosphere. It flattened 2,000 square kilometers of forest. Trees fell like matchsticks, scorched and stripped of their branches. Eyewitnesses reported a fireball brighter than the sun, and that was over an uninhabited wilderness. Now picture Tunguska over a city. A fragment from Atlas could streak into our skies, explode miles above the surface, and unleash a shockwave powerful enough to shatter windows for dozens of miles, collapse buildings, and kill hundreds of thousands instantly. Not from fire, not from radiation, but from pure atmospheric pressure. Entire city centres could be erased in seconds. This is not the Doomsday asteroid Hollywood loves to show, but it is every bit as terrifying. A small impactor is harder to detect, harder to track, and harder to stop. And this is where the domino effect becomes clear. If Mars is seeded with debris from Atlas, the inner solar system becomes a shooting gallery for decades to come. NASA, ESA, and other agencies do track near-Earth objects. They have telescopes scanning the skies every night. But here is the uncomfortable truth: the system is designed for predictable orbits. Asteroids that circle the Sun on known paths, comets that return on schedule. Atlas fragments would not follow those rules. They would come from unusual angles on unpredictable timelines. Our current warning systems might not see them until days, maybe hours before arrival. Think about what that means for preparation. If we detect an asteroid years in advance, we can launch missions to deflect it. We can plan evacuations, harden infrastructure, prepare society. But if an Atlas fragment is spotted on a collision course a week before impact, what then? There is no time for rockets, no time for elaborate defences. All we can do is try to move people if we even know where it will hit. And remember, the Tunguska object did not even reach the ground. It exploded in the atmosphere. A direct hit would be worse. If a 100-meter fragment slammed into the ocean, it would trigger mega tsunamis across entire coastlines. If it hit land, the crater could swallow a city, and the firestorms that followed could burn for hundreds of miles. These are not abstract scenarios. In 2013, a meteor only 20 meters wide entered over Chelyabinsk, Russia. It exploded with the force of several nuclear bombs. The shockwave injured over 1,000 people, mostly from broken glass. That rock came without warning. No telescope spotted it until it was already inside the atmosphere. That was just 20 meters. Atlas fragments could be twice that size or larger. Now combine that reality with Atlas's unpredictability. If the comet sheds debris during its encounter with Mars, those fragments may follow orbits that intersect with Earth over the next decade. Not one event, but a series. A new Tunguska every few years, a new Chelyabinsk every few months. The threat is not a single strike, it's the creation of a hazard zone that lasts for generations. And here's the part. No one wants to say out loud, we are not ready. Planetary defense programs are underfunded compared to the risks they face. Telescopes cannot see every small object, especially if it comes from the direction of the Sun. Deflection technology exists only in experimental form. Governments are not prepared to evacuate entire cities on short notice. The insurance industry has only just begun modelling these risks, and the public is barely aware of them at all. So when people ask, what's the worst-case scenario with Atlas, this is one of the answers. It does not have to kill Mars. It only has to scatter debris that eventually finds us. One fragment could devastate a city. A series of fragments could destabilize global society. Supply chains would break. Economies would collapse. Fear would spread faster than the fireballs. Remember what happens on Mars will not stay on Mars. The dominoes are lined up. If Atlas tips the first one, Earth could be next. For decades, Mars has been more than a red dot in the night sky. It has been mapped, measured and monitored by a fleet of machines. There are eyes and ears circling the planet day and night. There's the Mars Reconnaissance Orbiter, or MRO, with its powerful camera capable of spotting objects smaller than a desk from orbit. There's MAVEN studying the thin atmosphere and its interaction with solar wind. There's Mars Express, Europe's long-serving explorer, still sending data after nearly 2 decades. And there's the Trace Gas Orbiter, TGO, searching for chemical signatures that might hint at life. Together they form a network, a nervous system stretched across millions of miles. Every rover on the ground depends on them. Curiosity and Perseverance send their images through them. Ingenuity's flight logs are relayed through them. Without the orbiters, the rovers are like stranded hikers with no radios. Now imagine this Atlas sweeps past Mars, trailing its cloud of plasma and debris. Electrical chaos floods the upper atmosphere. One by one, the orbiters detect something they can't handle. Their computers trigger safe mode. Safe mode is designed to protect a spacecraft. It shuts down instruments, points solar panels at the sun, and waits for instructions from Earth. It is supposed to be temporary, but safe mode only works if communication is possible. If the interference is too strong, the signals never get through. Picture the control room at NASA's Jet Propulsion Laboratory. Engineers sit at their consoles, eyes fixed on screens. They expect daily updates, images of Martian valleys, measurements of atmospheric pressure, weather reports from orbit. Instead, the screens go blank. Telemetry disappears. Data streams collapse to nothing. The only sound in the room is the steady hum of machines waiting for signals that never arrive. Minutes pass, then hours. The silence stretches into days. And here's the problem: this silence is not just technical. It is psychological. For the public, Mars is not just a planet. It is a story. Every new picture, every new discovery is shared online broadcast on news channels used in classrooms. If that stream of discovery suddenly stops, what do people think? They don't imagine electrical interference. They don't think about plasma storms. They think something catastrophic has happened. They think Atlas destroyed our machines. They think Mars itself has been damaged. In the absence of data, imagination takes over, and it spreads fast. News anchors ask if we've lost contact forever. Social media invents conspiracy theories by the hour. Some claim governments are hiding the truth. Others claim scientists miscalculated and Mars has been struck. The silence itself becomes the story. Meanwhile, inside, mission control engineers keep working. They send command after command, hoping one gets through. They wait for a faint signal, a heartbeat from orbit. But until that happens, they are just as blind as the public. The real nightmare is if all 4 orbiters go down at once. MRO, MAVEN, Mars Express and TGO, every single satellite in safe mode. That would mean no relays for the rovers, no data on the ground, no eyes in orbit. Mars, for the first time in 2 decades, would vanish from our scientific map. Think about how fragile that makes our presence. Billions of dollars, decades of engineering, tens of thousands of people working for years, and one electromagnetic shock can turn it all dark. And this is not speculation. We know how vulnerable spacecraft are. Solar storms have disabled satellites before. Electrical interference has fried circuits. What makes Atlas different is scale. The plasma cloud it drags behind is bigger, denser, and far less predictable than anything we normally face. So the scenario is simple. A comet passes by. Mars glows with auroras. Our orbiters shut down. And suddenly the most studied planet in the solar system becomes invisible. This is the technological trap. Not fire, not craters, not dust, just silence. Silence that leaves engineers staring at blank screens and the public wondering if Mars itself has disappeared. Part 8. Atlas and the Sun, the Star's Wrath. Hook. What happens when a strange visitor provokes our star? When we think of threats from space, most of us imagine rocks, asteroids, comets, impact craters. But there is another kind of danger, one far more powerful one that does not come from outside the solar system, but from the center of it, the sun itself. The sun is not calm. It is a fusion reactor balanced on the edge of chaos. Every 11 years, its magnetic activity peaks. Solar flares burst. Coronal mass ejections, CMEs hurl clouds of charged particles across the solar system. Usually Earth takes the hit and survives. Our magnetic field deflects most of the energy. Power grids absorb the rest. Satellites get shaken but recover. But what happens if something disturbs that cycle? What happens if a comet like Atlas, an object with an enormous tail of ionized gas, passes close enough to interfere with the sun's magnetic field? This is not pure fantasy. The tails of comets interact with the solar wind. They distort it, twist it, even funnel energy in strange ways. Atlas, with its massive carbon dioxide coma and unpredictable behavior, could be the perfect trigger. If it crosses the wrong magnetic line at the wrong time, it could unleash a storm larger than anything in recorded history. Picture this. Atlas rounds the sun. Its plasma tail stretches millions of miles, colliding with the solar wind. The sun responds with violence. A CME explodes outward, not in one direction, but many supercharged by the comet's interference. A wave of particles races across space at nearly the speed of light, aimed directly at Earth. Now picture Earth the moment that storm arrives. Every GPS satellite goes dark within minutes. Your phone no longer knows where you are. Planes lose navigation. Cargo ships drift off course. Power grid transformers overloaded by induced currents shut down in a chain reaction. North America plunges into blackout. Cities from New York to Los Angeles lose power. Airports ground every flight. Planes in the sky scramble to land using only visual rules. Hospitals switch to backup generators, but fuel is limited. Banking networks stall. The internet backbone collapses without synchronized timing signals. Within hours, global communication begins to fall apart. We have seen smaller versions of this before. In 1859, during the Carrington event, a solar storm so strong hit Earth that telegraph lines sparked, and operators were shocked by their own equipment. Auroras were seen as far south as the Caribbean, and that was in the age of wires and Morse code. Imagine Carrington in the digital age. Imagine it multiplied by 10. Modern civilization runs on electronics. Satellites guide our cars, track our weather, connect our calls. Power grids carry energy across thousands of miles in fragile balance. A single superstorm could break that balance instantly. And unlike other disasters, this one is global. There is no safe zone. Think about the speed. An asteroid impact would at least give us time to track the rock. The particles would reach Earth in less than a day, maybe even hours. Not enough time to shut down the grid. Not enough time to shield satellites. Not enough time to prepare. And the damage would not vanish when the storm ends. Transformers take months to replace. Satellites destroyed in orbit are gone forever. Communication networks, financial systems, aviation, all would be crippled for weeks, maybe months. Some regions could take years to recover. The nightmare scenario is simple. Atlas interacts with the sun at the worst possible moment during peak solar activity. The result is a storm so intense it tears through every defense we have. Not an asteroid crater, not an impact, just invisible energy shutting down a civilization. This is the risk that keeps some scientists awake at night. Because it is not science fiction. It has happened before on a smaller scale, and it will happen again. The only question is when and how bad. If Atlas is the trigger, the answer could be sooner than we think. So when we ask what Atlas might do, we cannot only look at Mars, we must look at the Sun. Because if this comet provokes our star, the consequences will not stop at the red planet. They will come screaming toward us. And when they arrive, our modern world could go dark in a matter of days. What happens when a strange visitor provokes our star? When we think of threats from space, most of us imagine rocks, asteroids, comets, impact craters. But there is another kind of danger, one far more powerful one that does not come from outside the solar system but from the centre of it, the Sun itself. The Sun is not calm. It is a fusion reactor balanced on the edge of chaos. Every 11 years its magnetic activity peaks. Solar flares burst. Coronal mass ejections, CMEs, hurl clouds of charged particles across the solar system. Usually Earth takes the hit and survives. Our magnetic field deflects most of the energy. Power grids absorb the rest. Satellites get shaken but recover. But what happens if something disturbs that cycle? What happens if a comet like Atlas, an object with an enormous tail of ionized gas, passes close enough to interfere with the Sun's magnetic field? This is not pure fantasy. The tails of comets interact with the solar wind. They distort it, twist it, even funnel energy in strange ways. Atlas, with its massive carbon dioxide coma and unpredictable behaviour, could be the perfect trigger. If it crosses the wrong magnetic line at the wrong time, it could unleash a storm larger than anything in recorded history. Picture this. Atlas rounds the Sun. Its plasma tail stretches millions of miles, colliding with the solar wind. The Sun responds with violence. A CME explodes outward, not in one direction, but many supercharged by the comet's interference. A wave of particles races across space at nearly the speed of light, aimed directly at Earth. Now picture Earth the moment that storm arrives. Every GPS satellite goes dark within minutes. Your phone no longer knows where you are. Planes lose navigation. Cargo ships drift off course. Power grid transformers overloaded by induced currents shut down in a chain reaction. North America plunges into blackout. Cities from New York to Los Angeles lose power. Airports ground every flight. Planes in the sky scramble to land using only visual rules. Hospitals switch to backup generators, but fuel is limited. Banking networks stall. The internet backbone collapses without synchronized timing signals. Within hours, global communication begins to fall apart. We have seen smaller versions of this before. In 1859, during the Carrington event, a solar storm so strong hit Earth that telegraph lines sparked, and operators were shocked by their own equipment. Auroras were seen as far south as the Caribbean, and that was in the age of wires and Morse code. Imagine Carrington in the digital age. Imagine it multiplied by 10. Modern civilization runs on electronics. Satellites guide our cars, track our weather, connect our calls. Power grids carry energy across thousands of miles in fragile balance. A single superstorm could break that balance instantly. And unlike other disasters, this one is global. There is no safe zone. Think about the speed. An asteroid impact would at least give us time to track the rock. The particles would reach Earth in less than a day, maybe even hours. Not enough time to shut down the grid, not enough time to shield satellites, not enough time to prepare, and the damage would not vanish when the storm ends. Transformers take months to replace. Satellites destroyed in orbit are gone forever. Communication networks, financial systems, aviation, all would be crippled for weeks, maybe months. Some regions could take years to recover. The nightmare scenario is simple. Atlas interacts with the Sun at the worst possible moment during peak solar activity. The result is a storm so intense it tears through every defense we have. Not an asteroid crater, not an impact, just invisible energy shutting down a civilization. This is the risk that keeps some scientists awake at night. Because it is not science fiction. It has happened before on a smaller scale, and it will happen again. The only question is when and how bad. If Atlas is the trigger, the answer could be sooner than we think. So when we ask what Atlas might do, we cannot only look at Mars, we must look at the Sun. Because if this comet provokes our star, the consequences will not stop at the red planet. They will come screaming toward us. And when they arrive, our modern world could go dark in a matter of days. For decades, scientists and visionaries have talked about terraforming Mars, transforming the red planet into a second Earth. The idea is simple in theory: release greenhouse gases, warm the atmosphere, melt polar ice, and create conditions where humans could one day live. But what if instead of humanity carefully reshaping Mars, a comet like Atlas, does the job for us only in the wrong direction, Atlas carries more than ice and rock. It drags a massive cloud of carbon dioxide and dark dust. If even a fraction of that material falls into the Martian atmosphere, it could tip the delicate balance of the planet's climate. Here's what that might look like. Dark dust from Atlas settles across the Martian surface. Normally Mars reflects sunlight off its pale deserts and bright polar caps, but dust absorbs heat. Dark patches grow warmer, melting nearby ice faster than expected. Water vapor enters the thin atmosphere, mixing with carbon dioxide from Atlas. Together they create unstable chemical reactions. Some may form corrosive compounds, acidic fogs that fall back onto the surface. At first it might look like progress. A warmer Mars, more vapor in the air, signs that the planet is waking up. But the process would not stop where we want it to. The climate system on Mars is fragile. Small changes can spiral into extremes. Temperatures could swing wildly hot during the day, plunging at night. Dust storms triggered by new heat sources could cover the entire globe, lasting for months. Now imagine astronauts arriving in this environment. They plan for a cold, thin atmosphere. They design habitats and machines for predictable conditions. Instead, they face chaos. Instruments detect strange chemical signatures. Acid corrodes equipment. Solar panels clog with dark dust. Life support systems meant to recycle air and water break down under contamination they were never built to handle. Mars would no longer look like a candidate for a second Earth. It would start to look like a smaller version of Venus. Venus, after all, is the cautionary tale. Similar in size to Earth, it once may have had oceans, but a runaway greenhouse effect transformed it into a hell world. Surface temperatures hot enough to melt lead, an atmosphere thick with carbon dioxide and sulfuric acid clouds. Spacecraft that land there last only hours before they are crushed and destroyed. Atlas could push Mars in that direction, not to the same extreme, but far enough that colonization becomes impossible. Picture Mars after the encounter. The poles streaked with melted ice, flooding lowlands briefly before evaporating into the unstable air. Dust storms carrying acids that etch the surface of rocks. A sky tinted not just red, but brown and yellow with haze. Temperatures swinging so fast that machinery fails. A planet more hostile after Atlas than before. And here is the bitter irony: for decades humans dreamed of using comets to help terraform Mars. The idea was to redirect icy bodies, crash them into the planet, and release water and greenhouse gases. Atlas looks like that dream made real. But nature does not follow our scripts. Instead of delivering exactly what we need, it could deliver too much too fast in the wrong form. Terraforming requires control. Atlas offers chaos. The long-term risk is even more frightening. Once the balance shifts, there is no easy way back. Mars could enter a new climate state, one we cannot reverse. Its atmosphere, once stable enough for careful study and exploration, could become unpredictable for centuries. And that changes more than science. It changes psychology. For generations, Mars has been the symbol of hope, a backup planet, the next step for humanity. If Atlas transforms it into a chaotic wasteland, that hope collapses. The red planet, once imagined as our second Earth, could become a second Venus. Think about what that means. Billions of dollars in missions wasted, colonization plans abandoned, an entire future rewritten by a single comet. This is the danger of reverse terraforming. Not a sudden explosion, not an impact crater, but a slow, invisible shift in chemistry and climate. A shift that takes our dream of life on Mars and turns it into a warning about how fragile planets really are. So when we ask what Atlas could do, we have to imagine not just destruction, but transformation. Because sometimes the worst-case scenario is not losing Mars in an instant. It is losing Mars as a future, losing it to a climate spiral that leaves it forever out of reach. When truth disappears, rumor wins. Not every disaster comes from rocks, radiation, or plasma. Some come from silence, and silence is exactly what we face during Atlas's closest pass to Mars. Astronomers call it a solar conjunction. That's when the sun lines up between Earth and Mars, blocking our view. Radio signals have to pass too close to the sun, where interference scrambles them. For weeks, maybe longer, we cannot get clear data from the red planet. It is like watching a storm through a keyhole. Most of what happens we simply miss. And that is when the chaos begins. Imagine the timing. Atlas, an interstellar comet behaving unlike anything we've seen, sweeps near Mars just as our ability to observe collapses. Scientists know this is routine. They know conjunctions happen every 2 years. But the public doesn't see routine. They see blackout. They see silence. And silence begs to be filled. What fills it? Rumour. Now picture your news feed. One video claims Atlas struck Mars, wiping out every rover and orbiter. Another claims NASA is hiding evidence of alien life found in the comet's dust. A third claims governments already knew Atlas was artificial, a machine sent by another civilization. None of it is true, but truth is not what spreads fastest online. Fear is. Social media thrives on drama. Algorithms push the most extreme content to the top. A quiet official statement data is temporarily unavailable. Due to solar conjunction, cannot compete with a headline screaming Mars destroyed or NASA cover-up. People share the dramatic version. They like it, comment on it, spread it until it becomes the dominant story. Meanwhile, the real scientists are forced to wait. They cannot send or receive reliable data until Mars moves out of conjunction. For them, silence is expected. But for the public, silence looks like deception. Now imagine the effect. Families turn on the news looking for updates. Some channels invite experts who calmly explain the situation. Others invite voices who speculate wildly. Within hours, the story fractures into competing realities. In one version, Mars is fine. In another, Mars is gone. In yet another, governments are deliberately hiding the truth to avoid panic. Think about what that does to trust. For decades, space exploration has built credibility through transparency. Every new photo from a rover, every milestone from an orbiter has been shared publicly. People feel they are part of the mission. But if that flow stops, if silence replaces discovery, then trust begins to erode. People stop believing the scientists. They believe the influencers, the conspiracy channels, the loudest voices in the room. And this is the deeper danger. Losing data is temporary. Losing trust is permanent. Picture the engineers at NASA and ESA. They sit in mission control refreshing screens that show no new information. They know the silence is normal, but outside their walls the world is spinning into chaos. Politicians demand answers. News anchors speculate. Social media trends with hashtags declaring the end of Mars exploration. For ordinary people, the silence is unsettling. Mars has been a constant stream of updates for years. Photos of dusty landscapes, weather reports, selfies from rovers. When that stream stops, the absence feels louder than the data itself. People are used to instant answers. Waiting weeks for clarity feels like proof that something is wrong. And then come the fakes. Doctored images appear online showing explosions on Mars or alien structures in Atlas's tail. Edited videos claim to be leaked transmissions from spacecraft going offline. Amateur astronomers streaming from backyard telescopes misinterpret what they see and post confident claims that spread faster than corrections. By the time official data returns, the damage is already done. The conspiracy theories have roots. Some people will never believe the real reports, no matter how detailed or transparent they are. The narrative battle has been lost before the facts even arrive. Now imagine the consequences. Space programs rely on public funding. If enough people stop trusting agencies like NASA or ESA, future missions could be delayed or cancelled. Politicians under pressure from constituents convinced of cover-ups may slash budgets. The entire push to explore Mars could stumble not because of Atlas itself, but because of the stories told during the blackout. And here is the paradox: the real danger may not be physical at all. Atlas might pass by harmlessly. Mars might remain untouched. But if the world believes otherwise, the result could be just as damaging. Suspicion, mistrust, and misinformation can cripple exploration as effectively as a plasma storm or a fragment impact. The lesson is brutal. Data is power, but silence is poison. In an age where information spreads faster than light, losing the narrative can be worse than losing the mission. So when we think about Atlas, we have to think beyond craters and chemistry. We have to think about perception. Because if we cannot control the story controls us. The worst-case scenario here is not Mars destroyed. It is Mars unchanged while humanity tears itself apart arguing about what really happened. And once trust is gone, no amount of truth can bring it back. What if in a single day Mars became a graveyard? Let's imagine the extreme. The worst-case scenario not as scientists calculate it, but as storytellers of disaster. One fragment of Atlas large, fast, unstoppable, does not miss. It does not glance off or burn away. It strikes Mars head-on. The fragment is not massive compared to planets. It is only a few hundred meters across the size of a neighborhood or a skyscraper. But speed makes it lethal. Traveling tens of kilometers per second, it carries energy equal to thousands of nuclear weapons, enough to rewrite the surface of a world. Picture the moment of impact. Mars rotates quietly under the black sky. Then a flash erupts brighter than the sun itself. For a few seconds, daylight ignites across the entire hemisphere. Shadows vanish. The thin atmosphere glows as shockwaves rip through it. The explosion carves a crater miles wide. Rock vaporizes instantly. Debris shoots upward not in small arcs but in towers of fire and dust reaching into space. The plume glows, spreading outward until it blankets half the planet. Now think about what happens next. Every rover, Curiosity, Perseverance, even the tiny helicopter Ingenuity goes silent. Their solar panels are choked in darkness, their instruments overwhelmed by vibrations and electromagnetic chaos. Orbiters circling above try to capture images, but their sensors are blinded by dust. One by one they shut down, switching to safe mode or failing completely. Within hours, Mars is silent. Not just quiet as it always has been, but dead to us. Every signal cut, every eye closed. From Earth, the silence is crushing. For decades, we have grown used to a steady stream of updates, photos of landscapes, weather reports, scientific discoveries. Suddenly nothing. The screens in mission control show blank. The channels are empty. Engineers refresh their consoles, waiting for data that will never come. Meanwhile, the dust storm grows. Impact debris ground into fine particles spreads across the planet. Within a day, Mars is wrapped in a global haze. The sun disappears from its skies. Temperatures plunge. The thin air becomes saturated with grit, turning every valley and plain into a shadowed wasteland. Imagine standing there. The surface is dark at noon. Dust swirls so thick you cannot see more than a few feet. The horizon is gone. The red planet has become grey, lifeless, suffocating. This is not just the death of machines, it is the death of a dream. For generations, Mars has been humanity's backup plan, the next frontier, the place we imagined our children would walk in domes, grow food in greenhouses, build cities under alien skies. Billions of dollars have gone into preparing for that future. Engineers designed rockets, habitats, and life support systems with the belief that Mars would be there waiting. Stable, reliable. But in this scenario, all of it collapses in a single afternoon. Colonization is no longer delayed, it is erased. No one will build homes on a planet wrapped in choking dust for decades. No one will risk lives on soil freshly contaminated by alien debris. The future vanishes with the flash of a comet fragment, and the psychological impact might be even greater than the physical one. Humanity has always seen Mars as a symbol of hope, the next step in escaping the limits of Earth. If Mars dies, that hope dies with it. People would watch the news, see simulations of the impact, and realize the universe is not waiting for us. It does not care about our plans. But here is the critical point: this scenario is hypothetical. Astronomers calculate the odds of Atlas itself striking Mars as vanishingly small. The distances and trajectories do not support direct collision. This is not a prediction, it is a thought experiment. So why tell it? Because it forces us to confront the fragility of our ambitions. We plan as if the universe is stable, as if planets are safe, as if our technology can always adapt. But the truth is, one random fragment, one unpredictable event can undo decades of progress. The day Mars died is not a forecast. It is a reminder A reminder that the worst-case scenario is always bigger than we want to admit. A reminder that hope can be fragile, and that our grip on the future depends on forces we do not control. So no, Mars will almost certainly not be destroyed on October 3rd, 2025. But imagining that possibility makes one thing clear: the dream of colonization is not guaranteed. It exists at the mercy of comets, plasma, and chance. And if we are not prepared for that, the dream may end long before it begins. What if the strangeness is not random? Atlas has been called many things: unstable, unpredictable, chaotic. Its brightness rises and falls without reason. Its tail bends in strange directions. Its orbit shows slight shifts that don't fit the models. To most scientists, this is a puzzle, but to others it raises a darker, stranger question. What if this behavior is not natural? What if Atlas is not just a comet? What if it is a message? The idea sounds extreme, but let's think it through. For decades, the search for extraterrestrial intelligence SETI has focused on radio waves. Astronomers listen for signals that might be beacons from other civilizations. But what if other civilizations use methods we're not expecting? What if they use comets? Comets are visible across huge distances. Their tails stretch for millions of miles. Their brightness can change in ways that can be seen with even small telescopes. If you wanted to send a signal across the galaxy without building massive transmitters, you might use comets as the carriers. Now look at Atlas. Its behavior doesn't fit the usual patterns. Outbursts that flare and fade too quickly. Gas clouds that form strange shapes. Light variations that almost look patterned. Some researchers whisper, what if that is the point? What if Atlas is a platform deliberately engineered to get our attention? How would we test that? Science has tools. Spectroscopy, for example, splits light into a rainbow of colours. Every chemical leaves a unique fingerprint in that spectrum. Normally we use it to identify water, carbon dioxide, methane. But what if the fingerprint carries extra information ratios that line up too perfectly? Variations that repeat like binary code, a kind of cosmic barcode hidden in plain sight. We already use light to encode information in fibre optic cables. Could someone else use light from a comet the same way? Could Atlas be pulsing data waiting for us to decode it? Imagine what that would mean. Astronomers analysing data from telescopes like the James Webb Space Telescope might notice patterns that can't be explained by chemistry. Sequences of bright and dim timed too precisely to be random. Embedded information in the flicker of the coma. A signal carried not by radio but by the glow of dust and gas itself. If that were true, if Atlas is not natural, everything changes. Think about the impact on religion. Many faiths teach humanity is unique, chosen alone in the universe. Proof that another civilization exists would challenge those teachings. Some believers might see it as confirmation of creation on a larger scale. Others might feel their worldview collapse. Entire religious systems could split under the weight of new evidence. Think about politics. Nations compete for dominance on Earth. But if Atlas is a message, it is not for one nation. It is for everyone. How would governments respond? Would they share data openly or hoard it as a matter of security? Would rival powers accuse each other of hiding the truth? Would decoding the signal become the most important project in human history? And think about science itself. For centuries, scientists have assumed that comets are natural, that their physics can be explained by ice dust and sunlight. If Atlas turns out to be artificial, that assumption crumbles. The line between astronomy and archaeology would blur. We wouldn't just be studying rocks, we'd be studying technology millions of years old. Picture the global reaction. News broadcasts announce Atlas shows signs of artificial control. People flood the streets, some in celebration, others in fear. Stock markets tumble as uncertainty spreads. Conspiracy theorists scream that governments have known for years. Churches overflow with believers trying to reinterpret scripture. Politicians demand emergency summits at the United Nations. The entire planet tilts overnight into a new reality. And here is the hardest part: even the hint of this possibility could be enough. Atlas doesn't need to prove it is artificial. It only needs to act strange enough that we can't rule it out. The mere suggestion that it might be a message could destabilize society. Scientists would try to stay calm. They would insist on peer review, on careful analysis, on ruling out natural explanations. But the public doesn't wait. The public fills the gaps with imagination. If the official reports take weeks or months, the rumours spread in hours. By the time the data is published, millions may already believe Atlas is speaking to us. What would that do to humanity's self-image? For centuries we've told ourselves we are special, alone, the centre of our own story. Atlas as an artifact would destroy that illusion. We would no longer be the only intelligence. We would be one among many. And that realization could either unite us or tear us apart. Imagine if the patterns in Atlas's light turned out to be instructions, maybe mathematical sequences, maybe coordinates, maybe warnings. Even if we couldn't understand them right away, the idea that someone somewhere built this would drive us to decode it. Universities would pour resources into the task. Governments would classify their findings. The balance between secrecy and openness would become the central tension of our time, and yet we must face the possibility that it is nothing, that Atlas is natural, just unstable, that its patterns are coincidence, that we project intelligence onto randomness because we are desperate to find meaning. If that is true, then the real story is not Atlas at all. It is us, our hunger for connection, our readiness to believe. Either way, the outcome is profound. If Atlas is a message, humanity is not alone. If Atlas is not, humanity has shown just how much we long for company in the stars. The worst-case scenario here is not destruction. It is confusion. A planet divided between those who believe and those who doubt, between those who see a message and those who see noise. Because sometimes the most dangerous thing in the universe is not a rock or a storm, but an idea. Atlas is not just a test of science. It is a test of how we respond. So far, we've looked at Atlas as a scientific problem, a comet with strange behaviour, unpredictable risks and terrifying scenarios. But Atlas is also something else, a mirror. It reflects how humanity reacts when confronted with the unknown. And what that mirror shows is not always flattering. Let's start with governments. When Atlas first appeared, agencies like NASA, ESA and JAXA scrambled to collect data. But their announcements came slowly filtered through press releases and cautious language. Meanwhile, politicians debated budgets, argued over priorities and downplayed risks. The truth is simple bureaucracy moves slower than fear. By the time officials share their findings, public imagination has already run ahead. Next, look at the space agencies. Their scientists are brilliant, their instruments are precise, but they are also cautious. They avoid speculation, stick to confirmed facts, and refuse to make bold claims until the data is clear. That's good science, but it's bad communication. While scientists wait for certainty, the public fills the silence with guesses, rumours and conspiracy theories. Now think about the media. News outlets thrive on drama. Atlas behaves normally as not a headline. Atlas could destroy Mars's. Television, radio and online platforms amplify the most alarming possibilities. Social media accelerates the process. Fake videos spread faster than corrections. Influencers shout louder than experts. Within hours, a fringe theory can look like established fact. This is the real danger, not the comet itself, but the way we react to it. Imagine the sequence. Astronomers announce a temporary communication blackout due to solar conjunction. That's the truth. But by the time it reaches the public, the story is warped. People hear NASA hiding something. Social media adds fuel, Atlas impact confirmed. News channels invite talking heads who speculate about aliens or global disaster. The result? Panic. And panic kills. Think about what would happen if people truly believed Mars was destroyed. Stock markets could plunge. Governments could face riots. Public trust in science, already fragile, could collapse. None of this requires a single rock to hit a planet. It only requires weak communication, slow response, and a public primed to distrust. Now imagine something worse. What if the threat were real? What if an Atlas fragment were on course for Earth? Scientists would detect it. Governments would be briefed. Plans for deflection or evacuation would be drawn up. But would the information reach the public in time? Would leaders act quickly? Or would they stall, fearing panic until it was too late? History does not inspire confidence. Pandemics, natural disasters, economic crashes. We've seen how slowly institutions can react, how easily misinformation spreads, how often truth gets buried under politics. If Atlas is a rehearsal, humanity is failing the test, because the real test is not whether we can track a comet, it's whether we can coordinate, whether we can share information honestly, whether we can act quickly without tearing ourselves apart. Picture the alternative. A comet fragment is discovered on a collision course with Earth. Instead of clear instructions, we get confusion. One government says it's safe, another says it's dangerous. News outlets spin both sides. Social media screams conspiracy. Ordinary people don't know what to believe, so many do nothing. And when the impact comes, the lack of preparation kills more people than the rock itself. That is the nightmare Atlas exposes. Not destruction from above, but paralysis from within. And here is the hardest truth: fixing this problem is harder than building rockets. Rockets require engineering. Coordination requires trust. Trust in scientists, trust in institutions, trust in each other. Without that, even the best technology is useless. Atlas will pass one way or another. Mars will probably survive. Earth will probably remain untouched. But the real legacy of Atlas may be the questions it leaves behind. Are we capable of responding to a true cosmic threat? Or will we let politics, panic, and misinformation do more damage than any comet ever could? The worst-case scenario is not a crater on Mars or a blackout on Earth. The worst-case scenario is watching humanity fail its own test. The worst thing is not Atlas destroying us. The worst thing is Atlas giving us a chance to survive and us failing to notice. Atlas has been called a threat, a mystery, even a potential messenger. But in the end, maybe its real role is simpler. Maybe Atlas is a test. Not a test of rockets or telescopes, but a test of perspective. A reminder that we are fragile and that the universe does not play by our rules. Think about what Atlas has shown us. A comet can break apart without warning. Plasma storms can blind spacecraft. Dust can change the climate of a planet. Fragments can cross the solar system and threaten Earth decades later. And silence during those critical weeks of solar conjunction can unleash chaos in the way we share information. Atlas might pass by Mars without a scratch. Earth may remain untouched. But the lesson is not in the damage. The lesson is in the possibility. The knowledge that the sky above us is not empty, not safe, not predictable. So what do we do with that lesson? We prepare. Preparation means more than tracking comets. It means building systems that can handle surprise, faster communication networks, smarter satellites, stronger defenses against misinformation, the ability to act quickly without waiting for perfect certainty. We cooperate. Atlas is not an American problem or a European problem or a Chinese problem. It is a human problem. If fragments scatter across the solar system, they do not carry passports. They do not respect borders. The only way to face them is together. That means international cooperation, not secrecy. Shared data, not classified reports. A united response, not competing headlines. And we learn to separate truth from lies. The silence around Atlas proved how vulnerable we are to rumor. If people believe conspiracies more than scientists, no amount of technology will save us. The ability to tell fact from fiction may be the single most important survival skill of our time, because the universe will not wait for us to agree on what is real. Here is the uncomfortable truth: Atlas may be generous. It may pass by without harm. It may leave us with nothing but data and questions. That is the gift. A chance to practice, to get better before the next interstellar visitor arrives. But will we take that gift? Or will we waste it arguing, doubting, and pretending the danger is not real? Picture the future. Another object enters the solar system. Bigger, faster, closer. Scientists raise the alarm. This time the stakes are higher. Will we be ready? Or will we repeat the same mistakes? Slow communication, fractured politics, misinformation drowning out truth. The choice is ours. Atlas cannot make it for us. So maybe the real worst-case scenario is not impact or plasma or contamination. Maybe the real worst case is indifference. That we let Atlas pass, learn nothing, and remain just as vulnerable as before. Because the universe will not stop sending us reminders. The sky is full of wanderers, some harmless, some deadly. Each one is a warning shot across the bow of civilization. Atlas may not destroy us, but it has already given us the chance to ask the right question. When the next one comes, will we be ready?